Today's lesson is brought to you by the circle. Triangles having you down? Try the circle. It's round and beautiful. Alright guys, today we're going to start a new section, in fact a new chapter, something that we haven't done much this year, and that is circles. So we're going to go to section 10.1, learn about circles, arcs, sectors, and circumference. Not the noble knight circumference, but the math circumference. Okay, so here we go. Alright, so circles and arcs. Bunch of vocabulary words you guys should know. What a circle is. A circle is a bunch of points that are the same distance from a center. Okay, and if you see it, this right here, that shows you that's the center P. Alright, circles that have the same length radii are called congruent circles. Alright, the radii is half, goes from the center to the outside. So like PB is a radii, PC is a radii, PA is a radii. Alright, radius, there it is. Okay, so you got the center and the other end is the side of the circle. Alright, and there you go, what I just named. A diameter contains the center, but both endpoints on the circle. It's double the length of the circle's radius. So AB here represents the diameter. Alright, a central angle is an angle whose vertex is the center of the circle. Okay, so like there is a couple of them. We could have CPB and APC. Those are both central angles. Alright. So a large part of this lesson is on what arcs are. Arcs are simply parts of circles. Okay? And there are, a semicircle is an arc. Okay? It is half of a circle. And when you name an arc, you use this little arc shape here. It looks like a little arc. Hence the name arc. Okay, so this is TRS. Okay, and when you name an arc, you use either 2 letters or 3 letters. If it's an arc that's more than half of a circle, you're going to use 3 letters. All right, so like RTS. When you name an arc, you always go in the direction of the letters. Okay, so RTS goes around the circle the long ways. A minor arc uses only 2 letters, and so that helps to distinguish, you're only going the short way around the circle. RS and TR are minor arcs. Okay. Adjacent arcs are arcs that have one point in common. Okay, so like TR and RS would be considered minor arcs that are adjacent. Okay. And of course, in a circle, there's 360 degrees. A semicircle is half of a circle, and it's 180 degrees. All right, and so if you want to know the measurement of an arc, you just look at the angle that's inside of it. So like the measurement of arc RT would be the measurement of angle RPT. And to get the measurement of a major arc, you would take 360 minus the related minor arc. So if I wanted to figure out the measurement of RTS, I would take 360 minus the minor arc RS. Okay? Alright, in this example we're going to be working with identifying the arc. Alright, so let's see if we can do it here. Okay, the minor arcs. Minor arcs are AD and AE. Okay, and guess what? There is more minor arcs than that. You can say EB is a minor arc. Alright, DB is a minor arc. Alright, but to follow what the directions are saying, which is good to read the directions here, we're only doing the arcs with point A as an endpoint. Okay, so this one is out. Okay, but this is a minor arc too. It's just not the one that has point A as an endpoint. All right, major arcs with point A as an endpoint. Let's take a looky here. All right, that would be ADE, okay, and AED, okay, so, and everything else would just cover the same amount of space, okay, so like AED, you could also name as arc, okay, ABD, that would be the same thing, so you don't have to list that one twice, because it's the same space, okay, you're still going like this around the circle. All right, and the semicircle, and there are two semicircles. Can you name them? All right, there they are. And let me get rid of that. Okay, very good. So, arc addition postulate. Okay, this is from the old book, so sorry the numbering's off here. But if you add two arcs together, you can get a bigger arc, which makes logical sense. Okay. All right, so in this example, we're going to be finding measurements of the arcs. Okay, so we're going to find the degree measurements of the arcs. Remember, there's 360 in a circle, 180 in a semicircle. So we're looking for the measurement of arc X, Y. Okay, so arc XY is, if you follow the arc addition postulate, you just add up the 2 degree measurements here. Okay. 56 plus 40. Okay, that's the measurement of arc XY. That's 96. All right, and then, don't want to get too ahead there, figuring out measure of arc DXM. DXM. So this is a major arc. So, all right, so you know DX, arc DX is 56, but then you also have this big chunk here, and that is 180 degrees. So, you can once again add the semicircle, 180 degrees, to the minor arc to get the bigger major arc, which is 236 degrees. All right, it should have a degree symbol here, by the way, which I'm not sure why there isn't, but put a degree symbol on that. All right, circumference. Okay, the other big thing in this lesson so far is circumference. It is the distance around the circle, okay? In order to find circumference, you need to use the number pi, okay? And to be precise, you should use the pi key on your calculator. And if you don't have a fancy calculator, just type in what pi is equal to, which I hope you all know is 3.14 for the approximation. All right, and it keeps on going, okay? That's just the approximation. All right, so there are two ways you can find the circumference. You can use the diameter and multiply it by pi, which is pretty simple. Or you could take the radius, double it, okay, and multiply it by pi. They write 2 pi r, but you could do 2r pi. All right, double the radius, multiply it by pi. All right, and pretty simple to find the circumference. But you need to know these formulas. They're going to be very, very helpful for the next thing, which is arc length coming up here. All right, but before we get to that, this is just some random vocab word. In case you are interested, concentric circles are circles that lie in the same plane and have the same center. So these two circles will be concentric because their center is the same. All right, but the more important definition here is arc length, which is a fraction of a circle's circumference, okay? So it's like the distance. So you have a circle, the whole way around the circumference. The arc length would be the distance from here to here, okay, on the circle, okay? And it could be really any distance around the circle. Arc length. Distance around the circle partways, okay? That's arc length. And once again, the theorem number's off, but the arc length is just a fraction of the circumference, okay? So if you can figure out the measurement in degrees of the arc, you put it over 360 because that tells you what fraction of a circle it is, and you multiply it by the total circumference, which is from the formula 2 pi r, you could figure out the arc length, okay? The new book, okay, and I put this down here, the new book writes the formula like this, okay? n over 360, when n is the degree measurement of the arc, times 2 pi r is equal to s, which is the arc length. And when n is the measure of the arc, and you should put like in degrees, I have to remember to add that to the notes. Alright, so you need to know like how many degrees the arc is, which you can actually find right here, and that's the same as the outside there. So the measure of the central angle is equivalent to the measure of the degrees of the arc. You put that over 360 and you multiply it by 2 pi r. Alright, let's look at an example here. Find the length of this arc ADB. Alright, now this one's a little bit tricky because you don't have the degrees given to you, but you can easily find the degrees by taking 360 minus 150, okay? So there's the formula, okay? So we need to figure out what number of degrees over 360 times 2 pi r. All right, so first, what's r? R is 18. Very good. All right, now what is the degrees? 360 minus 150 is equal to 210, okay? Because, you know, there's 150 here, so this area is 360 minus 150, which is equal to what you're using, okay? So you're looking for the degrees of the arc over 360 times the circumference, which is 2 pi r. All right. Now after this, it says in terms of pi. So you don't get out your calculator and just multiply all this in, then divide it by 360. If you're estimating, that's what you would do. But since it says in terms of pi, you have to reduce this down, and it's sometimes a little tricky to reduce it down. All right, so what I like to do is first cross off my zeros. Then I mean, you could reduce this fraction in the calculator right away. Okay, if you have the ABC key, you can type 210 over 360. 210 ABC 360, it'll reduce it for you, which is nice. But you know, 21 and 36, okay, the 21 could become a 7, the 36 could become a 12, okay, and then you could reduce like the 12 and the 2 here, okay, you could reduce this more, this could become a 6, alright, the 2 would become a 1, and you can reduce the 6 with the 18, and that would become a 3, and you see, just reduce a whole bunch of stuff, and you get 21 pi. Isn't that nice how it reduces so perfectly? And you're left with 21 pi. Now, if you want to, you can put the pi key in the calculator and figure out how many units it is in centimeters. This would be 21 pi centimeters, which is 21 times 3.14 centimeters, and that would give you the decimal approximation for it. But we're going to be precise and just leave the pi key in, because if it says in terms of pi, that means you leave the pi in the problem. Alright, so here are a couple try it problems. Alright, and I want you guys to give it a try. Notice in the first one it says round to the nearest tenth. Okay, but in this one it says in terms of pi. So, go for it, and we'll go over it in a second. Alright, let's go over the first one here. So, you're going to use this formula, which is the formula for arc length. You put 80, which is 80 degrees, that's what they give you, over 360, and you multiply it by 2 pi r, which is how you find the circumference of the circle. So remember, it's a fraction of the circle times the circumference of the circle. And what I did from there, in case you're wondering, is a lot of reducing. Okay, I crossed out these zeros, and I reduced the 4 with a 36, and I made it into a 9. Okay, and then I did 8 times 2, which is 16, over 9, so 16 ninths pi. And then you need to put it in your calculator because it says round to the nearest tenth. So in the calculator, I get 5.6 for this one, approximately. Okay, and this is how you do B here. You first need to figure out the measurement of arc AD, which is 360 minus these other arcs that are given to you here. Okay, so arc AD is 140. Okay, then you use that same formula. Okay, you put 140 over 360 and you multiply it by the circumference. You cancel a bunch of stuff like we've been doing, and you get 28 over 9 pi. And it's okay to leave your answer improper like that. So like, you know, once again, it's up to you guys how you want to cancel, but, you know, just do your best with canceling, and it should reduce nicely, okay, to a nice reduced improper fraction. You could use the ABC key on your calculator, reduce it real quick if you have one, or just do the best you can with reducing. All right, guys. Hope you have a great day. We'll see you next time. Bye-bye.